Hi there. In this video I'm going to be looking at a fuel injection fault with this Honda Deauville 2007 plate NT700VA. The fault in question appears to be to do with the throttle position sensor. So in this video I'm going to look at how to diagnose the throttle position sensor fault, how to read the indicator light, and also hopefully I'll be looking at replacing the throttle position sensor, because in this case I have already done my diagnosis and that appears to be the faulty component. So if you've got a modicum of DIY experience, I would like to think that you should be able to do this yourself at home. However, if not, definitely take it into a motorcycle dealer to get it done. First things first is what is the fault and how do we know what that indicator light is telling us. So on the bike itself, you'll see when I put the ignition on, sorry, the FI light comes on as part of its normal check, and then it should go out and stay out. As you can see, it's blinking lots of short blinks. If you count them up, you'll find there's 8 short blinks. So as I mentioned, the FI stands for fuel injection, and them indicator lights direct you to what the fault is within that. So reading the the Haynes manual for the Honda Deauville, it will tell you in that manual that 8 blinks, which is what it was given us, relates to the throttle position sensor. So in my ignorance, I thought a throttle position sensor would be located somewhere nearby the throttle itself, but under further inspection, the throttle obviously is operated underneath the airbox, underneath the fuel tank, in the throttle body itself, and the sensor is attached to that. It's quite complicated to get to, but throughout the video I will show you how to get to it and hopefully replace the sensor. First things first though is how do we diagnose what the fault is. I've mentioned it's throttle position sensor, but what about it? Is it the sensor? Is it the cables? Or is it something else? So the first thing I'm going to do is try and access the components in the vehicle. Again, if you're fully aware on how to already take out the seats and some of the fairings, even the fuel tank, you could skip this part of the video and just come back to the fault finding. But for those who are new to it or would like to know how to do it, stay tuned. To remove the seat on the Deauville, everybody's will be slightly different depending on the age and the condition, but ultimately there's a key lock and the grab rail, which when you open it should unlock the pannier. This one, because of the age of it, the pannier locks don't work properly anyway, so somebody's put a clasp on to allow it to be closed and keep shut. Once you're inside the pannier box, on this top left hand connection, you'll find a lever. By pulling that lever, that will release the seat at the back. Not easy to do with one hand. So with that seat back mechanism released, the seat only comes up probably about ½ an inch. But what you need to do now is pull the seat back towards the rear of the vehicle. And what that does is it releases 2 of the fixing mounts underneath the seat, as well as the one at the front. If you just pull it back towards the rear, you'll see that the seat is now clear of its fixing mounts and it can be released. So the seat fits under there. Also has 2 brackets in which the seat fits under as well. With the seat off, I can now gain access to a side fairing. This is only held on by push fit fittings, sliding in clips and Velcro. So we'll start off with this bottom plastic. Just pull it forward. There's a piece of Velcro in here and a tiny little clip. There's also a clip in this location, so if you pull that forward there. And there's also a clip at the top, which again you pull forward. Now down the side here, there's a couple of brackets which sit inside this plastic. There's also a sliding one which fits in there as well. So now we just need to pull it up and away from the vehicle. From here you can do a number of tests from the ECM, which is an engine control management unit. It's an electronic component. There's a black 33 pin connector, and there's also behind this security bracket a grey 33 pin connector as well. Like I say, it is a security bracket. These nuts cannot be released from the front here. They're welded to the bracket. The actual way of releasing this bracket is by taking the ECM forward out of its fixings, accessing the other side of it where you'll find bolt heads. So in order to test the fault on the throttle position sensor or the cabling, we have to understand what cables we need to test and also what they do. There are only 3 cables connected to the throttle position sensor, and all 3 of them come or go to this ECM. If we look at the wiring diagram, you will see the throttle position sensor is here. It has 3 cables going to it, one red and yellow, one yellow and red, and one green and orange. So if we trace them back to the module, you'll see the green and orange goes through the map sensor, but you can see they're connected, and also the throttle position sensor and map sensor has the same yellow and red cable. That basically is the 5-volt feed that goes to the throttle sensor. So we've got 5-volt positive and a negative. If you follow them 2 cables back up, you'll see they're both attached to the engine control module on the black 33 pin connector on pins 18 for the orange and green, green and orange, and pin 9 for yellow and red cable. So they feed the throttle position sensor, and now based on which position the throttle's in, there will be a return voltage that comes from it, which will vary between somewhere between 0.4 of a volt DC up to 5 volts at wide open throttle. I'll show you where I got them figures from later, but they come from the Honda workshop manual. So this is fed from the black ECM control module connector, and the return red and yellow cable goes into the grey module, the grey connector in the module on pin 31 out of the 33 pin connections. So there's different tests we can do. There's continuity tests, so we can check to make sure that there's a continuous connection from this wire all the way back to its pin number 18. We can do the same with number 9 to the throttle position sensor wiring harness. We can also do it on the red and yellow cable, which goes to pin 31 on the grey connection. We can also check that neither of these have a short circuit to each other or down to earth. There's some basic checks we can do, but in order to do that, we need to gain access to the throttle position sensor's wiring harness, which in itself is quite awkward to get to. Like I said before, it's under the tank and under the airbox. So before we get to that point, there are some other tests you could do, in which case that might prevent you having to go into so much trouble to get to this sensor. So what I'm going to do, we know that there needs to be voltage at the throttle position sensor. We've mentioned that pins 9 and 18 provide the 5 volts. We've also mentioned that pin 31 on the grey module, sorry, the grey connector on the module has the return voltage. In the Honda workshop manual, it will stipulate the low voltage side, which is basically when the throttle's closed or off, should be between 0.4 volts DC and 0.6 volts DC. Anything in that range, and that is what is acceptable. When the throttle is wide open, the voltage that is returned from the throttle position sensor should be in the range of 4.3 volts DC up to 4.9 volts DC. That obviously allows for any loss in the resistance of the cables. So from the module we can test whether we're getting that return voltage and if it's within parameters. It also notes in the Honda workshop manual that there's only 2 faults on the throttle position sensor that could cause the 8 blinks on the dashboard. But without having a pocket tester, you won't know which one it is. But 8.1 is low voltage at the throttle position sensor, and 8.2 is high voltage on the upper side of the throttle position sensor. So basically, if we can get this module out, test the pin for the return voltage or the output voltage. If it's testing low on the low side, that'll be why you're getting the 8 blink flashing. If it's testing high on the high side, that'll be why you're getting the 8 blink flashing. So we need to find out what the readings are before we figure out why the readings are the way they are. So on to testing then. I've explained how to release this. I've got the clip at the top. You can just pull that out of the clip. And my wiring harness is a bit tight. If yours is slacker than mine, you may be able to get both sides of the module up and above its fixing bracket. In my case it's a bit tight, but I can get the top, sorry, the left hand side as you're looking at it, out. And then I can obviously slide it out from the right hand side of the bracket. You can obviously now visualise the colour grey for this connector and black for that connector. These are the security fixings I was talking about, which are Allen bolt heads, and mine are a bit rounded and not easy to get out, so I haven't bothered in this case, and I don't think it's necessary to do so. Not very easy to see, but as you look at these pins from the furthest away, that red little blank cap I'm looking at now, that would be pin number 1. This one at the uppermost as I'm looking at it would be pin 33. So when I was talking about pin number 31 on the grey, you can see the furthest would be 33, working back would be 32, red and yellow would be 31. Which is good because that's what colour it's supposed to be and what position it is supposed to be. This is the output voltage from the throttle position sensor. It's a bit more awkward to get the other ones I was referring to, which was 9 and 18, because they are 1, 2, 3, 4, 5. This one behind there in the middle row, that is the green and orange cable, and the black one's a bit further at the back. Not the black one, sorry, the yellow and red. So, really, these two I've just talked about being awkward to get to. They provide the input voltage to the sensor. So, if we're looking at the output sensor, if we're getting voltage there and it's within range, we don't need to check the input voltage is correct, because it has to be if the output voltage is correct. If we're not getting the correct output voltage, or if we're not getting any voltage, obviously that's when you might want to check the input voltage, because that might be a part of the problem itself. So in order to test the voltages without removing the ECM, because if you remove the ECM and then you turn the ignition on, you obviously might not get the voltages that you're expecting, because the ECM obviously needs to do its business. The way to do it, I've seen a number of people doing it different ways. Basically, you need to try and get something long and metal and slot it in to the back of this terminal, and then you get a connector probe onto that to test for voltage. I've seen people use pins, and you could also use a sewing needle. What I'm going to use for mine is a piece of copper core from an earth cable that I've got. It's a multi-core earth cable, not very focused there. I'm going to snip a piece of that off, push it in, and then we can test the voltages from there. So here's what I've just made off camera. You might just be able to see it. Copper cable in the red and yellow hole. You have to be sure that you push it far enough down, then obviously you make contact with the metal electrical pin inside the terminal in order to make sure you're getting voltage. So once that's in position, you'll need a voltmeter. It needs to be set on the DC range or direct current. And that's indicated by the solid line with the dashed lines underneath. So hold on that and make sure it's on the correct range. This one's an auto ranging one, so it will give you the right range that you need. But obviously you're only measuring up to 5 volts DC, so anything within a 0 to 10 volt range should be adequate. Just for simplicity, I've got a crocodile clip on the end of this one, and I'll be connecting that to the copper wire. Obviously all of this is done with the voltage off, as in the key isn't being turned on yet. With the other piece, I'm just going to connect it to the negative terminal to test for the voltage. You could try and find the pin in there, which is the green and yellow pin 18, and measure the voltage across that as well, because that would also prove that you've gotten a good negative connection on the actual throttle position sensor. I have done this previously and checked it, so I know that is fine. So in this case, just for simplicity, I'm going to use the battery terminal negative. So if we turn the ignition back on, runs through all of its checks. At the minute we have 0 volts. Once I connect the negative terminal, I should be expecting 0.4 to 0.6 volts. That's connected now, as you can see, 0.02 volts. Clearly that is a lot less than expected, and that is the reason for the fuel injection warning light, because it's expecting 0.4 minimum and it's well below that. So obviously I've got my voltmeter connected to the negative and the output voltage from the throttle position sensor. I am getting some voltage, but not anywhere near what I'm expecting. That could be for a number of reasons, which we need to investigate further. But the way to test the throttle position sensor itself, you may be getting 0.4 here, which is great. What you can do is obviously open the throttle gradually, and then you can see the increase in the voltage, which demonstrates that the throttle position sensor is or isn't working. So in my case, I'm going to start opening up. Sorry, I'll open it slower than that. Okay, so that's a little bit open, a little bit more, a little bit more. As you can see, it's going up slightly. Getting me own way, sorry for the recording. There you go. But still nowhere near 0.4, which is the bare minimum. You can see 0.5. It's jumping around all over the place. The more I'm opening it, it's giving you some volt, but then it drops down to 0. So it should be giving you a steady increase from 0.4 up through the range, which clearly it's not doing. I'm going to whack it with wide open throttle. So as you can see, it's giving us the correct upper limit, 4.7. It will start rolling off gently. You see it is absolutely doing what it should be doing at the upper end of the range, and going down through steady voltage decrease, which it should do all the way down to 0.4. Comes to a point where it goes from 3, 2, and just dips. So on the lower end of the throttle range, it's definitely not working. So that's why I've thought, I believe it is actually a throttle position sensor issue and nothing to do with cables. If it was an open circuit, I would be getting no voltage at all because there would be a cable broken. Yeah, if it was a short circuit, I would also probably not be getting the right voltages either. But the fact it seems to be working at the top end and not the bottom end does indicate a fault. The interesting thing is though, the bike does run. So when you turn the bike on, the throttle operates as it should, or appears to on the low revs. When you take it out for a ride, the throttle does occasionally cut out, somewhere between 4,500 and 5,500 revs. And when I was reading onto the fault itself, it said its default or fail-safe position was 0 degrees, which is throttle off. So if and when I'm using the bike and riding it, if it then thinks it's at a fault state, it will just cut off to 0 degrees in order to make it a fail-safe. Obviously you want to fail to 0 miles per hour or 0 revs rather than 10,000 revs. So that's the first test that you can do to indicate whether you've got a faulty sensor or not. If your sensor is reading between 0.4 at the lower end all the way up to 4.7 or 4.9 at the top end, it's most likely you will not have a FI fault indicator light shown because it's within the parameters. If you do have one, it may be intermittent, may come on now and again. If that's the case, most likely you will have a dodgy wiring connector between here, the ECM, and the throttle position sensor cable itself, which, as I mentioned, is in underneath all of this. So that's the first test complete. So I talked about the input voltage for the sensor and how you can measure it at this location. So I thought I'd prove that it can be done. Again, you might not be able to see, I'll just get a screwdriver to try and point it out. You See just in front of me screwdriver tip there. That copper cable is poked into number 18, which is the green and orange cable. And why can't I get in there? Again, just in front of it there. Not very good. There you go. You see the red and yellow cable at the back. Sorry, yellow and red cable. Not to be confused with the red and yellow cable. And that's also in there. So these two, pins number 9 and 18 on the black, they are the input voltage for the sensor. As I mentioned, you shouldn't need to check that if you're getting an output voltage, unless it's slightly out of range maybe. But you can check it from here, and that means that the ECM is delivering the 5 volts required for the sensor. So again, just to demonstrate that, I've got the meter, it's on the voltage range. So the yellow and red is the positive connection, and the green and yellow, sorry, green and orange is the negative connection. And as you can see, getting exactly 5 volts across that, which means the output from the ECM is given exactly what it should be. If you're not getting 5 volts at that point, there's a good possibility that the ECM isn't functioning as it should be. What's worth noting at this point is if you were getting 5 volts across the two pins that I was, 9 and 18, then the ranges of 0.4 to 0.6 volts DC and 4.3 to 4.9 volts DC will be accurate. If you're getting any voltages less than 5, there is a note and there's a calculation within that to work out what your range would be. So refer to that if your voltage is not 5. Okay, that's most of the testing that can be done from here without removing any further fairings or fuel tanks. After that, of course, I'm going to have to remove the fuel tank, airbox, just to gain access to the sensor and also the wiring connector that goes to the sensor. Once we're at that point, we can disconnect the sensor and run continuity checks between the end of this harness into here and the end of the harness into there as well. But again, from these checks, I'm pretty confident that the wires from here are delivering the 5 volts to the unit, because the return wire from the position sensor at wide open throttle is giving me close to 5 volts, but within the range of 4.3 and 4.9. So I believe the wires are correctly going there and coming back. What I can't be sure of is if they are in any way shorting out perhaps and giving a different reading. But I can't really test for shorts with both ends of the harness plugged in. If that's plugged into the ECM, that other side's plugged into the sensor. You could start picking up readings through electronic components and it wouldn't give you a true reading of whether anything's a short circuit or not. So to remove the rest of the fairings that we need to gain access, we're going to have to remove the side inspection hatch. We're going to have to remove this side fairing to gain access to the tank, in which we're going to remove. So the next thing you remove is the side inspection hatch. This has a clip, push fit clip around the bottom here, which clips into this bottom fairing. So you need to pop that out first. Also, there should be some kind of fixing in here, but when I got the bike it didn't have one, so there may be a screw or Allen head bolt to be removed from in there. Once that screw's removed, once this clips out, the whole fairing just needs to be slid back over, because there are connections in here and along the bottom here. So to slide it towards the back of the bike, and as you can see, that's the fins I was talking about, the brackets that slide into their respective hooks. So not for now, but for later. There is a bolt in there which holds this plastic fairing to the tank, but clearly if we need to remove the tank, that bolt will have to be removed to release it from the fairing. That is a 12mm bolt, well 12mm nut socket head that you need to get the bolt out. Next we need to remove the top fairing. You need to do this for both sides, by the way, but I've already done the other side, but I'm just showing how to do it one side. Once you do one side, you just do it the other side. In order to remove the glove box, you need to take off the lid first. One side should be locked with the key, just need to release that. Once it's up, you just pull it towards you, and you'll find that that's just got a push fit connector. Again, yours might look slightly different. The one that I came with for me had an Allen bolt securing this. It didn't have any fixings in the top end, but as you can see, it looks like it should have. So again, yours might have two fixings in the top. So if there are, you need to remove them two fixings. This Allen bolt, which I've released earlier. And in the middle here, obviously you'll have both fairings attached to the tank. It holds the fairing to the tank, but also holds the tank to the frame. On this left hand side only, you'll see that there's also a couple of cables which are clamped, well not so much clamped, but resting inside the fairing itself, so they will need to be released in order for the side fairing to be lifted up. So release that, release them two bolts and nuts, and again using a socket set, release that bolt and washer. Which then should just allow the fairing to lift slightly. Now it's got some connections into here as well. On mine there's a Velcro connection roughly there, but also you'll find on the tank there's a metal tang that sticks out. So for this fairing to be released, you're going to have to lift it up from the Velcro and out away from the bike. It's this metal bracket I was talking about, and that's the slide connection it fits into. Now just a little bit of gentle manoeuvring, you should be able to lift and remove the glove box. You might find it easier to move a handlebar out of the way if you wish, but I didn't need to there, and it seemed to work fine. So that's given us access to the fuel tank. The fuel tank is hinged at the back end here with this bolt. Again, I've previously released this one because I've already done all this fault finding. but that should be tight when you come to release it. If you slacken this nut off, it doesn't have to be all the way off if you're not removing the tank, but by slackening that off and having released both of the bolts at the front, not forgetting on both sides, ensuring that this bolt has been removed also, the fuel tank can be lifted and can be removed. In this case, I'm just going to lift it and show you how to do it. As you can see, it's lifting on the hinge. And I'm going to use a little chop of wood at the minute, simply just to prop it up to show you how I do it. One thing I did find in the manual says you can lift it all the way up and bungee cord it from the top of the tank when it gets up to the back of the tank perhaps. But after having just filled the fuel tank to the brim, I found that I started leaking petrol all over the floor through the drain pipe. Not good. Moving around the bike now. Oh. You can see I've mentioned that bolt needed released in order for the tank to be lifted. This is the airbox, which contains a filter in there. It also feeds the throttle body, which I'm struggling to get a good view of from this angle. That's it there. So the throttle body assembly is this unit here, and if you can see, this is the throttle position sensor. So when the throttle is opened inside the throttle body unit, you have the butterfly valves, and based on the mechanical position of those, that will move this mechanism on the inside, which is a variable resistor. It will alter the resistance inside of there, producing the higher or lower voltages to the ECM, which will decide how much fuel to inject. If you can just see it there, the blue connection on the bottom. Okay. That is the connector, which we need to release to conduct further testing, which is why you need to take off the tank and the airbox in order to release that mechanism. If you're good, you could possibly access it from here. However, I wasn't very good and I couldn't do that. From the side inspection, you can get your hand in. As you can see, there's my thumb. It is possible if you can access the thing at the bottom and maybe just prying it with a screwdriver from the top. You might be able to pull it out, but even then you're still going to have difficulty accessing it with the multimeter in order to get any test readings done on it. So as I've mentioned, what I'm going to do is try and replace that throttle position sensor itself. I've read a number of times online that you can't buy these units separately, and it is a part of the throttle body assembly. So if you need a new sensor, you need to buy the whole throttle body assembly, which in some ways sounds a bit daft. In other ways, I can totally understand it. That throttle body has already been set up by a manufacturer. It'll have been calibrated, and that variable resistor will be set so it has the right voltages within the right parameters at the right stage of throttle on and throttle off. That being said, I do also see it as just being a variable resistor. So if the component you can get is a direct replacement, then it shouldn't be too difficult to calibrate yourself. So I've ordered one, found one online on eBay. It did say that it is for this model of bike, which is an NT700VA. I would assume that will work for all models of NT700, whether that's V or VA, between the 2006 and 2013 age range. And the reason I say that is due to that's the models that are covered in the Haynes manual, and everything seems to be specific to that era of bike. There's nothing saying for a 2012 model do this or a 2009 model do that. So as everything seems to be the same to get there, I would assume it's all the same component. So I was thinking about the FI warning light, and obviously the two states in which it could come on, which was the low voltage and the high voltage. Earlier I thought it might be the wide open throttle, which gives you the high voltage. So the alarm might be if there was an issue with that. However, that doesn't seem to make sense the more I think about it, because how would the bike know what that voltage setting is unless the throttle's open to wide open position? So what I'm thinking now is the lower range, or the range it's supposed to expect, is 0.4 to 0.6 volt DC. So the 8.1 fault, which was the low voltage, must be what I've got, where it's not sensing 0.4 volts as the minimum. So in some ways it probably thinks there's an open circuit, and therefore the voltage isn't getting back to the control module. Or the high voltage side will be if it's higher than 0.6, because that might, the bike itself, if it's higher than 0.6, may think that there's a short circuit on the circuit. So instead of it going through the resistor and coming back with the resisted voltage, which was down to 0.6, maybe come back with a higher voltage due to either a faulty sensor or a short circuit, or possibly even a dodgy ECM giving out too much voltage and then obviously giving you too much voltage back. Furthermore, just thinking about electrical connections in general, all electrical connectors can go through corrosion and oxidation based on the age and how exposed it has been to weather conditions. So it's always a good point to note that when you're doing any electrical testing, that these connector blocks are the weak points where the cables are terminated. So anytime you're making break connection, be checking, make sure there's no loose wires, and any oxidation, corrosion, debris, dirt is cleaned out. Possibly using some kind of electrical contact cleaner, spray. And that's really what we're doing all the continuity tests for and the short circuit tests for as well, just to prove that they are in good condition. In this circuit, there's only really four connectors, but three places where they will be connected. Clearly the TPS sensor has a connector block. We've seen, obviously, the ECM has two connector blocks, the grey and the black. What I haven't shown you is in between them two. So this is on the left hand side of the bike, just beneath the fuel tank, bolted onto, that's not bolted on, so you clip onto the metal chassis itself. There's a grey multi-pin connector. That one there also is in the circuit. So you can see the red and yellow and red cables. There will also be the green and orange in there as well. So it would be useful if you can to separate that connector block and also check for any loose connections, dirty connections, corrosion, and to address it. Although it looks fairly simple to get your hand onto it, it's quite challenging, particularly to have enough grip to separate the two connections. It does appear to be a waterproof connector, and that as well making it a bit more tight, so it's not separating as easy as you might expect. You can get to it with your hands, it particularly makes it more helpful if you remove this module. I don't know what it's called, but it's just air hoses connecting to it from the airbox and the air filter element box. Quite simple to remove all these tubes, and that module itself, as you can see, is just a push fit connection as well. I'll be removing that as part of the airbox element when it comes out, which gives you a better hand-on purchase for that. Likewise with the TPS, if you go through the inspection element around the back, you can also get your hand onto it. But again, I've had great difficulty in getting the two separated. Hopefully you have more luck doing it if you need to. Okay, on to the fuel tank removal then. For me, like I say, I'm going to remove the fuel tank purely because it's a full tank, and I have tried to hinge it back and it did spill fuel on the floor. If you don't have a full fuel tank, there's a chance you may be able to hinge it back and do all the work without having to remove the tank itself, which will obviously be a lot more helpful. So again, just for ease, I've already separated this connection, but there's wiring harness and the connector that comes straight out of it. It's just a push fit connector. Obviously has a locking pin, so depress the locking pin, slide it open, and that wire is what powers the fuel pump. You'll also find that the wire is connected or held in place by a bracket, which is connected to the tank hinge bolt, fixing bolt. So it'll have to be released because the cable will come off with the tank. If we're removing it entirely, obviously that bolt's going to come out, as will the bracket. Now, moving on to the other side of the tank, which is where the rest of the work needs to be completed. In here, under the tank, you'll see we have two fuel pipes coming out. I say fuel pipes. One's a drain pipe, breather pipe, sorry, for the tank. One's a drain pipe or an overflow pipe. And the only other element is the actual fuel pipe itself. So this is the one that gives fuel from the fuel tank, and it goes all the way down into the throttle body assembly. So obviously the fuel pump's been disconnected. These drain and breather pipes are just push fit, so it might be tighter than others. At this point in the manual, it does recommend that you turn the ignition on, start the bike, and run the bike until it is starved of fuel. What that should do, because the fuel pump's been disconnected, it's not going to feed new fuel in, so any residual fuel that's in the fuel pipe and in the throttle body assembly will get used up and should lead to less fuel being spilled when you disconnect this pipe. That being said, it's worth having a rag or some kind of cloth handy, because even with all that done, there's a chance that there will be some fuel spillage. Fuel is very flammable, so be very careful when you're removing the fuel pipe. Make sure you've got no hot components or any electrical sparks that could ignite any fuel vapor. To remove the fuel pipe, again it's going to be very difficult to demonstrate with one hand, so I'll talk through it and then I'll do it without videoing and show you the end product. On the fuel pipe itself, I'm making it a bit more challenging because I can't hinge the tank back far enough, so there's not as much hand space for me to get to. If you can hinge it further back, you'll have a lot better access than I've got. As you can see, the outside green clip, there's a press clip on this side and there's one on the reverse of it as well. Both of those need to be pressed in at the same time. Once they're pressed in, this inner clip should be released from the black outer side, and you should be able to push the whole green mechanism out from the black, thus releasing the black fixing to be pulled away from the metal fuel pipe from the tank. So I'll turn the video off for a moment, undertake that work, and then show you what it looks like once it's removed. So I've managed to disconnect the fuel pipe, as we talked about, and it was a bit awkward. Like I say, I didn't have as much height because of the amount of the tanks raised to get in there, and obviously it's right at the back of the tank as well, so a little bit more awkward. What I found quite useful were long nose pliers. I was able to have the green clip inserted like that, so I could access the top and bottom. I was able to get the long nose pliers on the top and bottom and squeeze the two clips together. So once them two clips were squeezed together, they released the black push fit, which just needed to be pulled away from the fuel tap, from the fuel pipe, and then obviously dislodged. Prior to that, the fuel hose was clipped in to this bracket, so just by pushing it I was able to release that. And also at the other side it was clipped in at this bracket, so again, just for more flexibility on the pipe, I withdrew that from that bracket as well. It gave me a bit more flexibility on where I could position the pipe in order to withdraw it. I did get a little bit of fuel that came out, and obviously I had my rag handy, so that's all good. So now that's all of the connections for the fuel tank itself disconnected, so the fuel tank is literally ready to be lifted up and placed on the ground. So if you haven't already, this nut needs to be released. There's a lock nut, so we'll need to release it all the way off, and once it's finally removed, that is the final piece of the jigsaw. We just need to pull that bolt out from the other side, and that will free the tank up to be lifted and put onto the ground. Again, that is going to be a two-handed job, so I won't be able to show you how that gets done, but I will lift it up, put it on the ground, and again, yeah, I'll show you how that lands on the ground as well. This bracket here, I found when it goes on the floor, stops all of this, all of the gubbins underneath from hitting the ground or fouling the ground. There's only one on this side of the tank, not one on the other side. But if you let it go, it will rock forward onto that side of the tank. So I tend to use something to prop it up with as well. So that is the fuel tank removed. Wasn't too difficult. Pulled that bolt out with the tank still in a raised position. Nothing moved. The tank was still fitted snugly inside that bracket, and obviously it was still on the chopper board at the top. I've removed it, brought it to the ground, And it is sitting nicely on the back, and as I mentioned before, it does clear the gubbins underneath. However, it is quite unstable, so just for security I've used that same chocolate board with weighs this time, so that tank is nice and secure and it's not going to go anywhere. Happy days. Next thing I'm going to be doing is removing the airbox. To do so, a number of posi headed screws fixing it, including one in the centre. There's also a number of sensors connected to the box. I'm not sure what each of them are. I know one's called an IAT sensor, one's a map sensor, and another sensor. I'm sure there's 3 sensors in total, as well as a number of air tubes which also connect to the box. So there's nothing really technical about it in a sense. All you need to do is disconnect them and also remember where they go. So I'm going to remove that sensor cable. I'm going to remove the top sensor cable. Obviously, with all cables, make sure you're careful not to damage anything, because each of these sensors, no doubt, are valuable to replace as well. So those are unplugged. Come down to this manifold that we talked about earlier. Best way to do that, I've already unclipped that one, as you can see. Sorry, there we go. So we should be able to remove that pipe from the box. That's removed from the airbox. There's another one just under there. Remove the metal clips, by the way, you just squeeze them together, just like butterfly clips. That pipe's probably going to be easier to come off as I lift the box up, because then I'll just be able to pull it against the pipe itself. We'll go around to the other side of the bike, where I've been doing most of the fuel tank removal. You'll see that, there we go, this sensor that I have removed, you'll find there's also a little air pipe that goes in there as well. So again, that just needs to be plucked off. So that's it for this stage. Now we just need to take all the screws out. The one I started earlier. And I'll just whip through the rest. Or like I say, just posi head screws. So with all the screws removed from the airbox housing, not forgetting the centre one, top of the box just lifts up. Again, that shouldn't be of any surprise to anybody. That's where your air filter is. Air filter itself is just simply drops in position. So now this bottom section of the box is only held in by these 2 tubes, which is where your throttle valves are located. Obviously as they open, that's where the air comes in, the filtered air, to go to the engine to mix with the fuel. So you can see the two screws either side of that tube, and same for that tube. I'm going to loosen them. The two tubes are going to come off, and also that bottom box can be lifted. So slacken those screws off now. Obviously not all the way off in this case. And that just lifts out. Two pillar screws. And the other side, as mentioned, should come straight off because I've already loosened them. Same setup, two pillar screws on the bottom of them. And now that airbox should lift up. Bear in mind we still have this pipe connected, so we'll need a little bit of force just to lift that above there. Perfect. Ah yes, that module is still plugged into the airbox as well, so I just need to lift that out from that. So once I had two hands free, I was able to pull that out. The bottom box lifts up from the back and then pull towards the back. The front air scoop just sits under that metal bracket. When it refits in, that's why I have to lift it at the back first and pull forward. So now we're getting somewhere near. We can now see the throttle body assembly in its entirety. So if we needed to replace the whole lot, which is what initially was indicated, this would be the whole unit that needs to be removed. In principle, it's not too difficult, and I'm probably going to have to remove it to access the throttle position sensor. What you'll find is there's some rubber boots mounts here, which are basically screw clamped together. So by releasing the screw and the clamp, should release the base of the throttle assembly on this chamber. This one over here, it's the same principle, but as you can see, that screw is going to be a lot more challenging to get to. But not without a challenge. So I wish I could show you how I'm able to get access to here, but like I say, two-handed. It is two-handed, so I need one hand to operate the phone. But you can see that the clip has been removed slightly. What I did was I poked a finger down from above. I was able to engage the locking mechanism for the clip. Sorry, I was able to disengage the locking mechanism with my right hand. With my left hand I was able to push down on the blue clip with a screwdriver, flathead, and that was able to break it free enough so that I was able to just release it. Yep. So that was the mechanism released. So going underneath now, I'm able to gain access to it. And then obviously poke it back through, which gives me access to do some testing on it. see the cables. I see the condition of them. Yeah, so you can see they've got some corrosion on them, on that part of it. Definitely some dirt in there. But the terminals themselves look healthy and shiny. I will spray it with some contact cleaner anyway, just as a good practice. So I'll give it a little spray anyway of contact cleaner. Still looks a bit dirty around the outside because I haven't actually got any cloth in there or anything. But from there we can do some tests. You may notice I've also put some kitchen roll just through any of the open pipes in case anything did accidentally get into the pipework or was still into the engine block. So, testing, what I'm going to do now, continuity test. We can check from our multi-pin connectors to the actual sensor, which will confirm we're getting continuity through that junction block as well. Excuse me. So I'm going to start with the red and yellow on the grey cable. Like I say, I'm pretty sure I've got continuity because I am getting the voltage on there, albeit it's an irregular voltage on the low throttle side of things. I know from the wiring diagram that the centre pin is the one that gives the output voltage. So I've just got again a bit of a copper core. That's set to continuity and gives a beep if it makes continuity. So as you can hear and see, we do have continuity between the two. You can also test between the other terminals. Make sure we haven't got any dead shorts. That's the inside and the outside. No buzzing. No dead shorts between the cables. Just to make it more simple, I'll remove this connector block. Maybe not that simple. Certainly more simple with two hands. Right, so because we've pulled that wiring harness out now, also we can access this side of the terminals. If you remember, we're looking for pins 9 and 18. Number 1, because the orientation of it is the bottom left through to 11, 22, 33. So we're looking for number 9, go to 11, go back to 10 and 9. And that, if I remember, is the yellow and red cable. So if we come into this, I know it's not the centre pin, so it'll be left or right. Just try the right one, it's not that. Try the left one, full continuity. And if I try number 18, which is again counting back from 22, 21, 20, 19, 18, which will be the other outside one, which will be the right in this case now. Direct continuity, go to the middle, no shorts. The outside one, a little beep, got some resistance there. So with the ohms range, you'll find it's 8,000 ohms, which is a lot. It's not a direct short, but it is something to consider. That is the black and orange, sorry, the green and orange cable, which ultimately becomes earth when it's plugged in, so I'm not that concerned. What am I? So those are the continuity tests. I'm definitely getting them. Short circuit, there are some high readings but no direct shorts, so bear that in mind, but it's not going to put us off from what I'm going to do at the moment. So what I did online, like I say, I bought a new TPS. I'm hoping it's the right shape, size, model, orientation, resistance, but really I won't know until I try it. That's the position that has been given to me. You can see the clock, if you want to call it the clocking of it. The right hand side is up towards 2 o'clock perhaps. The bottom side is down towards the 7, 8 o'clock. The rotation of it is anti-clockwise. So again, hopefully that position and the clocking position is the same as the sensor I'm going to take off. Hopefully it's the correct orientation, as in both go anti-clockwise. And hopefully the voltages that come out are the same as what goes in. On the Honda workshop manual, one of the high voltage tests, if you had a high voltage fault, it does say you can test across the pins, and I would have to look at which of the 2 pins it is. I think it's the outside and the middle, but don't quote us which outside and middle. It does say that there should be a resistance between half a kilo ohm, which is 500 ohms, and 1.5 kilo ohms, which is 1500 ohms. I have tested this one just to see if we're in the ballpark. It is in the ballpark. It's not exact. It is giving us a slightly higher ohmic value, about 1.9 kilo ohms. So I decided just to check it again, just to show for the camera really, but it's now showing that it is within the parameters that are set. So the 2 pins in which you had to measure the resistance across was the outermost one, if the sensor is facing towards the vehicle, and the centre pin. So like I said, it had to be somewhere between 0.5 and 1.5 kilo ohms, which is 500 to 1,500. And it is currently sitting at 730, which is within that parameter. Effectively that's 0.73 kilo ohms. That's a good sign, and hopefully bodes well for the rest of this. What I have done as well, just for test purposes, is to operate the variable resistor. As you can see, it does go through the range. There doesn't seem to be any breaks in continuity. That's just jumping from a different range to a different range. It's going from thousands to kilo ohms, and comes all the way back down at 800 this time. So it's still within the range. Like I say, that is a good sign, bodes well. What I've decided to do is test to see if plugging in the new throttle position sensor to the wiring harness gives me the right readings, the right voltages. See if it actually clears the fault. That'd be useful. So what I'm going to do is, I've got that plugged in. I'm going to go back to red pin 33. Plug that one back in as well. Go on the DC voltage range, and I'm going to test the voltage across the output sensor. If you remember, the initial test I'd done across the output sensor voltage wasn't quite consistent throughout the range. So I'm going to see if this one is. So I've got a sensor plugged in, got my voltage meter set up, DC voltage. I'm going to turn the ignition on, hope nothing blows up. And one warning light. 5, 6, 7, 8. Okay, so it hasn't cleared the fault yet. Voltage 0.01, which is about what I had on my sensor. However, I'm not totally disheartened yet because the position sensor isn't in situ. As you can see, the two fixing screws are holes on the end of slots, so this can be fixed either rotated left or right, and obviously that calibrates the starting voltage or position. So let's operate it a little bit, see if the voltage changes. Okay, so I can get 0.4 to 0.6. That's the current clocking position, that's the original. So hopefully when it goes on, I can calibrate it so it starts at 0.4 to 0.6. Keep going around the range. Definitely steadily increasing compared to the current sensor that's in position. Oh yeah, let's just change the range again. It's an auto range changer, so if I go back down again, you'll see it's showing 3 digits after the decimal. And it's going to jump up just to 2. I'm not concerned with that, that's not a jump in the throttle. And almost 4.9. Spot on. So not all's lost yet. Hopefully I've set the starting position at 0.4 to 0.6. That will fix the fault. But that does mean I am going to have to remove the throttle body assembly and the throttle position sensor and replace it with this one. So I'll loosen these off camera on that side and one on the other side. Can't see from this angle. And take it from there. Well, I'd be lying if I didn't tell you. Sorry, if I told you that was easy. It wasn't. You see this bolt head here on the clamp. Very difficult to access due to the space that you had around it basically. I took out another number of sensor plugs. There's one here on the back end. This one at the front. There's a 2-pin one there. Got a 3-pin one there and a 4-pin one there. Once the clamps are both removed, I had to unbolt them all the way just to make sure. Still took some force to lift the socket ends of them, or the male ends, out of the female rubber sockets. But anyway, that's out. And like I say, hopefully this is all going to be worth it. I'd be very disappointed if after all this, 1, it doesn't work, or 2, it's even worse, and it doesn't work at all. Right, the next thing to do, remove these 2 Torx head bolts. It's not the security tape with the pins in the middle, just regular Torx heads. Looking at the pins, that to me does confirm that there was no corrosion. So I don't believe there was a dodgy connection at this end anyway. And likewise there. So I do think it has a faulty sensor, everything seems to be pointing to that. So I will remove it and I will replace the new one. Hopefully it's the same orientation, because it does seem to go through the voltage range as expected. So managed to get the throttle body assembly off. After you've rotated it 90 degrees up. The fixings were what appear to be Torx head. I say that because the T25 Torx head seemed a bit too small, but the T27 seemed a bit too big. When you look online, it doesn't appear to be a T26. And due to the condition of them, they were pretty solid in there. Managed to get around it by using the T27, hammering it into the bolt head, so it got a really good grip on it. I used a wooden wire brush to rest the throttle body assembly on while I was doing the hammering, so as to not damage anything. That did get a good hold, and I used a shifting spanner on the back of the Torx head fitting to release it. Thankfully. So, the moment of truth. It looks to be the same clocking position. And if you give me a moment. I'll check to see if it spins in the same direction. And it does. So I think you hear that, but it sounds a bit grindy inside as well, so all good signs that the actual sensor might be damaged. So I've replaced that with a new one, because it looks to be the right shape, size, position. Just to double check on the size. Yeah, all appears to be the same. Cool. Finally, we'll try it and see if it works. Getting there. So, I have fingers in the way. Fitted unit. I've just randomly placed it in the center of the slots to give us play up or down. So what I'm going to do is turn the voltage back on, testing again on the output side. So I had one flash there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Looks as if the 8 blinks aren't there anymore, which is a good sign. Ah, look at that. 0.49 within range. If I operate the throttle now. Yep, it's going to go up. I won't do it too much though, because I do have the throttle bodies open. And I don't want any junk getting in there. Fantastic. Looks like it's going to work. What I don't know is what the ECM has been calibrated for with regard to the throttle. So I don't know if it would be better off at 0.4 or 0.6. It's going at 0.495, which is bang in the middle. So I think I will accept that. And then obviously try running the bike and see how the throttle response is. See if it needs any tweaking. So I've now fully secured the throttle position sensor, which as you can see the voltage has dropped slightly, so there must have been a slight bit of play when I tightened up the screws, but I'm still happy with that being 0.492. I've also excuse me, slightly repositioned the way the throttle assembly is sitting, just so I can test the full range of it before I actually bolt it back down. So I'm going to go through the throttle range. Yeah, see, hopefully it's going to go up gradually. So that is wide open throttle. It's giving me 4.4 volts DC, which, as per the workshop manual, it did say the range is on the upper limit 4.3 volts to 4.9 volts. So again, it's still within range, although I was expecting it to be closer to the higher end of the range, or at least midpoint, because obviously the starting position is midpoint on the lower end. So I'd assumed it would be more 4.6 rather than 4.4. So I don't know how that's going to affect the running of it, the throttle, or the idle speed. But I have been looking online, and there is a way to reset the ECM, which in itself should calibrate or self-calibrate to anything that's been reinstalled. In this case, the throttle position sensor should be able to pick up the new values if I'm able to drain the memory from the ECM. Should be able to pick up the new values and set them and assign them accordingly, so that the throttle and the idle speed and everything is sweet as a nut. But we'll have to try that out at the end. So I'm going to go and put everything back together, taking a lot of care to make sure that I don't miss any hose pipes getting reconnected, any electrical plugs getting reconnected, and making sure all the things seat exactly as they should do. So yeah, I'll move on to refitting the throttle body. I think what I will do is look into maybe changing that clamp around. As you can see, the bolt head is on the outermost side of the vehicle. That's the bolt head there. But because of the proximity to the frame, it was quite a challenge to loosen. So if I rotate that 180, so that the bolt head's at this side, hopefully I've got more access from this angle with a flexible screwdriver. Okay, that's the next step then. Okay, so I have managed to get all them fastened. It was slightly easier by turning it around, the clamp. Maybe you can just see it in there. So this was the screwdriver I was talking about. Excuse me. It's called a snake driver. That's what it used to be called, or a flexi driver. You can put different bits in the end. Obviously this is a posi head. You can put little sockets on the end as well, which may be useful. In this case, you can see you can get into some awkward places. Worked alright on that one, and this one down here was still awkward. me see the bolt head on it. Yeah, down there. Anyway, that was how I managed to get that done. So it is solid. I'm happy with that being refitted properly. As far as plugs that go in, if you're following along, I plugged in the throttle position sensor cable first before I even seated them back into the rubber mounts, because I knew how difficult that was to get in when it was seated. And once it was seated in place, I put this 2-pin connector in and one other connector, which is for the sensor here. There we go. I was able to clip that one on as well whilst it was in position. You see these two are on the uppermost part, so simple to get back on. Obviously I did take out the 2 pieces of tissue which were in the throttle body assembly before I put this back on. So far I'm happy that that has been mounted correctly. So I shall move on to refitting the airbox. To refit the airbox, I'm going to need to access that vacuum pipe or air pipe. Don't need the petrol drain pipe yet, or the breather pipe. This one here connects into the bottom of the box, and again these throttle butterfly valves need to have nothing in there. So that should be ready for refitting. Remember, the box has a scoop on the front. That scoop needs to slot in at a downward angle. Okay, that will go in, but it has just reminded me, with that cable being a bit loose, that there is a little clamp on the bracket, on the casing, sorry, there, to hold these wires in place. That's just getting in the way. So that should slot in there nicely now, and it does. Make sure underneath no pipes are going to get trapped. Oh, looks clear from here. It's just about trying to get these positioned now. So this is why I said check and double check. There's a sensor here, sensor cable, sorry, and if you can see it there, that little blue sensor sticking out the throttle body assembly, which I haven't yet connected. If I'm honest, I thought this connector was the one that goes to the airbox, but that's that one. So obviously need to plug that in. Ideally that would have been done when that was off, but I'm pretty sure I'll be able to get it in as it is. So I've managed to get that seated nicely after I fitted that sensor back underneath the throttle body assembly. And it's seated nicely in the little cutouts on the chamber. So again, make sure you fit all of the pipes and electrical connectors. It's worth noting that these only go in one orientation. You can see on that left hand black pillar, you can see there's a little extended piece compared to the other side. see that longer piece has to go to the outside. If you put it on the inside, obviously it won't fit because it'll come up against the inner housing. Quite simple to refit. Push them in and then screw them back down. So they're now fully screwed in, which I did off camera. Now remember the air filter element just sits neatly on top of those little raised black plastic plugs. And then the box lid goes on. And we'll screw them all back down, not forgetting the centre fixing as well. Again, I'll do that off camera for speed. So with the airbox lid fitted back on securely, I will now go on to fit the fuel tank in reverse of how I removed it. So the first thing I'm going to do is obviously put the tank on. I'm going to sit the base in here, and I'll basically rest it on its front mount as it was fitted properly. Get the securing bolt in, and then I'll be able to hinge it back up, prop it up with the chunk of wood, and then I'll be able to make the fixings for the fuel lines, breather hose, drain hose, as well as reconnecting the fuel pump wiring. Interestingly, the fuel pump isn't wired up, and as we've seen before, there's no fault light, which does surprise me. You'd imagine one of the biggest part of the fuel injection systems is the fuel delivery, so we'd imagine it would be a fault if there was no power at all. But hey, I'm not worried about that. So I'll put these on, again two-handed, off screen, and then we'll come back and show you how to fix the pipes back on. So the fuel tank's back on and in the raised position. Wasn't too difficult to put on. What is worth noting is when you put it on, it has to go on almost from the raised position, because can you see in that bracket? Yeah, so you can see that red extended piece there. That has to slot in that black bracket. So it has to come down at an angle before it gets dropped in. If you just try and put it in flat like I did earlier, it basically sits on top of there. And so it needs to be slightly raised in order for them extended pieces to slide down. But as you can see, I managed to get the bolt in. Didn't take any force. And obviously, not forgetting that cable clip, or pipe clip, for the fuel pipe. Sorry, the fuel pump electrical connection. Okay, so that obviously you had to align the green bracket clips with the hole that was in the hose pipe connection. What I found helped in this angle was to get a screwdriver in behind and actually push the black connection onto the green. Again, if you have more space than I do, it might be easier for you to do that. Also, when I first took the hose pipe connection out, this was already off. But obviously that is a mechanism to stop the pipe from coming disconnected. As you can see, it pushes in and out. And you push it in over the pipe, then obviously you can push it in to the green bracket. And what that will do is stop any accidental movement of that green clip. So I'm pressing on that now and it's going nowhere. So that's how it should be stored, and hopefully when you find it, that's how it should have been found. But obviously to remove it, you just need to pull it away. Final thing is put the hose pipe back in its clip. There you go, that's clipped back on that side. If you haven't already, perhaps you unclip it in order to get that back in. Make sure it's clipped in to the bottom of the airbox as well. Finally, we've got the two tubes. Don't forget to take out the pieces of tissue or rag, whatever you've put in there. And again, these shouldn't be hard to locate because there's two pipes with two different diameters. So, small one goes on the small one. And the large pipe goes on the large one. So, that, my friends, one fuel tank reconnected. Should be able to start up the ignition. Oh, not yet. I still need to connect to the fuel pump connector on the other side. So I'll do that. But after that's done, we should be able to turn the bike on. We should be able to hear the fuel pump sending fuel to the throttle body. I'm going to hold the camera here while I turn it on. Sounds good. We're ready to start. Well, I said I was ready to turn the bike on now, as I paused the camera and just went through a little mental checklist to make sure I had everything done. I went back to turn on the ignition and there was absolutely no power whatsoever to the dashboard, which obviously indicated that the battery was flat. Understandable, the bike hasn't ran for a while. We've had the front lights on for quite a bit while we're doing all the voltage tests. So that pushed me down one path, which I wasn't going to go down just yet. Initially what I was going to do was just start the bike and effectively see what changing the throttle position sensor had done to the idle and the throttle. So I was just going to test it, see how good or bad it was, see if it was rough or not. And then if it was working, I would have probably left it. If not, I would have tried to recalibrate the ECM to the new throttle position sensor. But because the battery was flat, I have had to disconnect it, put it on charge, and that really has kind of forced me down the path anyway of doing the recalibration. It's not a bad thing. So I've seen it in a number of different ways, but basically the one I was going to follow was by removing the battery, or disconnecting the battery for, I've seen a range of time up to 30 minutes. That should be enough for the ECM and all of the electronic capacitors to basically discharge and lose the memory. And then reconnect the battery and go through a little sequence which I'm going to do now, and hopefully that recalibrates the ECM. So I've disconnected the battery. It's been well over half an hour. To be fair, it's been closer to 36 hours, just because I haven't had a chance to get back to it. So it's been off, it's fully charged now. It's 13.4 volts in the battery, so that's a very good battery. When it was flat, it was down to 10, so it's proper flat. So really, what I'm going to do now is go through the little sequence. Number ones I've seen, most of them are pretty identical, whether it's a Honda bike or any bike or even cars, pretty much the same thing. Discharge the capacitors through removing the battery. In fact, some of them take off the negative terminal and put a jumper lead between the positive and the negative, and effectively that should discharge any positive charges in the capacitors down to the earth of the bike, and again leave that for a period of time, like 10 to 30 minutes. Once that's done, we think it's been discharged. Turn the ignition on, let it run through its pre-startup checks. Again, I've seen people say just leave it do that. Some people have said do that and leave it for 30 seconds. Again, there's probably something right between the two of them. With the throttle position sensor, I've seen one which says once you turn the ignition on, let it run through its pre-entry checks. It basically said run slowly through the throttle, close to wide open, and then turn the bike off. Turn it back on again, let it run through its pre-entry checks, and start up. So one person I've seen said that, which I'll do. I don't think it'll do any harm. But all the other ones I've read is just basically turn the ignition on, let it run through its pre-entry checks, and then start the bike. Once the bike starts, it might sound quite rough because effectively it's lost its memory. So all of the voltages, all of the oxygen sensors, throttle sensors, map sensors, etc. are all recalibrating themselves to each other. So you're supposed to leave the bike to run for a period of time without operating the throttle. So you just turn the bike on, let it idle, and again, most of the videos say run the bike until the cooling fan kicks in. Once the fan kicks in, you can then hit the kill switch, and that then is it recalibrated. But I have seen one further one which says let the fan run through a cycle. So it comes on, turns itself off, and then that is the bike recalibrated. The one I read that on was this bike in particular, so for the sake of an extra 5 to 10 minutes of running the bike, I will do that, and we'll see where it goes. But I haven't started the bike yet. The bike is cold. This ECM recalibration should be done from cold, because obviously all the sensors have to be from a cold starting position. Yeah, so first I'm going to turn the bike back on. Let's see if anything looks different. Okay, so that's its pre-entry checks done. Startup checks. As you can see, the engine light's not flashing, which is amazing. Bike is cold. I'm going to run through the throttle just to see if that does do anything, but most of them don't say you have to do this. However, because I've adjusted the throttle position sensor, so replaced it, I don't see any harm in doing this. Okay, so that's one wide open, down to closed again. Turn it off, and then turn it back on again. So I'm going to start the bike, cross my fingers and hope it actually starts. Started, and as you can see, the idle is jumping up and down, throttling around. And again, I've read that that's what this should do, because it's basically recalibrating the bike for the new readings that it's getting. So I'm not going to let this run for 15 minutes on camera. Once the cooling fan kicks in, I'll restart the video again. It hasn't yet got up the temperature, so the cooling fan hasn't kicked in yet. As you can see, you're still somewhere between cold and medium. You can see that the idle speed is definitely settled. Still slight fluctuation, but nothing compared to what was bouncing around earlier. That's good. Again, bred somewhere between 5 and 15 minutes it will take for the cooling fan to kick in, depending on the diagonal temperature outside. So, still, so far, I'm very happy. Yes, 14 and a half minutes. So the temperature, the fan kicks in normally gets a little bit point, so just over. And here the fan whizzing away, and it's just kicked itself back out. So I'm now hit the engine kill switch. Before I do so, you can see pretty steady there at about 1050 revs. Good. So hopefully that's all good. Main thing is it starts. I haven't run it through its throttle range yet, of course, and I'm going to have to take it out for a bike ride now. So that means boxing it all back up and getting her out on the nice open road. Fantastic. Final update on the bike then. I've had it out now, taken it for a test ride, and everything seems to be in good working order. And not that it really proves it, but obviously I had the battery off, which resets all of the clocks and the trip counters. As you can see, I've done 82.7 mile on one trip counter, and the other one I did reset it. That was one of the journeys I've just done. I did 60 miles on my first journey, which was 30 mile to one town, had some food, came back, and average 12.3 miles per litre. I'm not sure what the calculation is. I've heard it's multiplied by 4 or 4.5 to get miles per gallon. So even if it was 4, that gives us 48 miles per gallon, which, yeah, I'll probably get more than that. If it's multiplied by 4.5, then it will be more than that, so seems to be working in the right range. The rev counter pretty much gives us, well, ticks over at 1050 to 1100 revs on idle, which is on the lower end of what's expected. The book says, Haynes manual says 1200 plus or minus 100. So 1100 would be the lowest, 1050 slightly under, but doesn't seem to affect the bike in any way whatsoever. But like I said, all in all, everything seems to have worked. So for the sake of £25 for a TPS sensor, and granted a little bit of elbow grease, managed to get rid of my fault of the FI warning light, got rid of the problem where the bike was actually cutting out, sorry, the throttle was cutting out between 4.5 and 5,500 revs, and the bike actually now seems to be quicker off the mark, because it was a bit sluggish. But it's the first time I rode this type of bike. I wasn't sure if that was just the weight of the bike, but clearly the TPS did have a negative impact on that as well. So yeah, quite happy. That's the end of the video. If you've got any questions, I'm not a mechanic, but I'm an enthusiast or a DIY hobbyist. So anything I've told you is came from my experience and my knowledge, and a little bit from some of the manuals. But if you've got any questions, I'm willing to answer them if you've got them, and if I can. But also, if you've got any things that you want to tell me that I've done wrong, feel free. Adios.